Types of grinding operations we are going to see. First one is universal grinding, where headstock can be swiveled with respect to table travel. That type of grinding is called as universal grinding. And the next one is cylindrical grinding. It may be external or internal. Work or surface speed, work that is equal to 20 to 30 meter per minute. Grinding wheel speed 1500 to 2000 meter per minute can be obtained. The next topic is surface grinding. It is used to produce a flat surface in horizontal position. And then face grinding also is produce flat surface in vertical position. So, you can compare the surface grinding for horizontal position, flat surface, face grinding, flat surface, vertical position. The next one is form grinding. It is used to grind the gear teeth, threads, splines, shaft and holes. And the important question is the part of grinding highest peripheral speed will be obtained. And the snag grinding, it is used to remove the considerable amount of metal without regard to the accuracy of the finished surface. So, snag grinding, the accuracy is not important, but we are removing some amount of metal. You have to differentiate between the flange grinding and transverse grinding. It is used to grind the external diameter of workpiece equal to or shorter the length of the width of the wheel. Here, shorter the length of the width of the wheel can be produced, whereas in transverse grinding, work is reciprocate on the wheel feed to produce the cylinder longer than the width of the wheel face. Transverse, longer than the width of the workpiece can be produced. Plunge grinding, shorter than the width of the workpiece can be produced. Next, we are going to know about centerless grinding. It is a process of grinding the diameter of workpiece not mounted on the center. In cylindrical grinding, the workpiece is mounted on the center. In centerless grinding, it is not mounted on the center, otherwise hold. It may be internal or external. In this, workpiece is placed in the work rest. So, this is the work rest. The workpiece can be placed in the work rest. Blade between the grinding and regulating wheel, where one side is grinding wheel and another one is regulating wheel. Both the wheel rotate in the opposite direction of workpiece direction. Regulating wheel equal to surface speed 15 to 60 meter per minute. Grinding wheel 1500 to 2000 meter per minute can be obtained. Actual feed can be calculated by pi d n sin alpha, and the grinding ratio can be calculated by volume of material removed by volume of wear. So, here in this case you can see the external centers grinding setup, and here we are having the internal centers grinding setup. Pressure roll is there, support wheel is there, regulating wheel is there, and we are having grinding wheel inside the hollow cylindrical workpiece. என்ன பார்க்க போறோம்னா centerless grinding some more points பார்க்க போறோம். Actual feed நம்ம ஆல்ரெடி பார்த்தது தான். We are seeing the value of actual feed is 5 dn sin alpha. The workpiece center will be above the line of joining the two wheel center. So, we are having grinding wheel and regulating wheel whose center are joined by a line. That line will be below the workpiece center line, or workpiece center will be above the line of joining the two wheel center. Regulating wheel, the angle of inclination is 0 to 80 degree to create the automatic feed. It is suitable for long job. Work support throughout the entire length as grinding take place. No work holding device is required in some cases. Wear and tear of the machine is less, and rate of production is compared to cylindrical grinding is high, and rapid production process. Cost of production as compared to cylindrical grinding is less. So, cost is less and mass production will be obtained. Grinding wheel size is 500 mm, regulating wheel size is 300 mm. Grinding wheel surface speed is 1500 to 1800 meter per minute, and regulating wheel 15 to 60 meter per minute. Surface speed of the grinding wheel for grinding plain carbon steel is 1500 to 2000 meter per minute can be recommended. The difference between cylindrical grinding and centerless grinding is workpiece held and rotated between the dead center. Here, workpiece is supported and rotated by the arrangement of work rest and grinding and regulating wheel. Here, it has to locate at the center, dead centers, and in centerless grinding, it has to arranged by work rest and grinding wheel and regulating wheel. Grinding is done by feeding the rotating the grinding wheel against the work surface. Here, grinding is done by passing the workpiece between the grinding wheel and rotating wheel. So, there are three types of cylindrical grinding is there: through feed grinding, in feed grinding, end feed grinding. All are come under the category of cylindrical grinding. Through feed grinding is used for long slender shaft or bars. In feed grinding can be used for shoulders and formed surface. End feed grinding is used for tapered surface. Next we are going to discuss the topic called grinding wheel wear. In grinding wheel wear we are observing three things. One is attribution grinding wear, attribution grain wear and grain fracture and bond fracture. So first in attribution grain wear, cutting edge of grain become dull and round, which reduce the removal of material. It is similar to the flank wear of the cutting tool. So here we can see grains, and the grains are by bond fracture, and here you can observe the grain fracture. One phenomena is there, it is called as loading of grinding wheel. What do you mean by that, loading of grinding wheel? When chips will not find enough phase to flow out with the grinding wheel, then the chips get clogged within the interface. So it has to be clogged in between the grains. So that phenomena is called as loading. Loading is an unwanted phenomena. So reason behind the loading is when grinding soft material with dense structure, the loading act take place. If RPM of grinding wheel is low, loading will occur. If cutting fluid is not appropriate, loading will occur. Effect of loading on grinding wheel, it is because of the misalignment of the wheel and inaccuracy, difficult to remove more material, reduce surface finish and cutting force increases. These are the effect of loading on grinding wheels. So we are going to see some of the important points in grinding. Finish of the ground surface could be poor due to dulling of abrasive grains. When the abrasive grains get dull, the required finish cannot be obtained. Because of the odd wheel and high speed, wear of the abrasive grain take place and it produces the shiny appearance of the wheel. That process is called as glazing. So because of the glazing, cutting capacity decrease. So what happens? Because of the use of the odd wheel and high speed, wear of the abrasive grains take place. It produces shiny appearance that can be called as glazing. Because of the glazing, cutting capacity decreases. The process of restoring the cutting phase with the help of diamond tool is called as truing. The process of improving the cutting action with the help of diamond tool is called as dressing. Improve means dressing, restore means truing. Abrasive grains become clogged with particle being ground is termed as loading. So loading, dressing, truing, glazing. Among these four words, you can definitely get one question. The next thing we are going to know about the dressing, it is a process of sharpening the wheel if its edges get dull. So if edges get dull means we have to sharp. So that process called as we are improving the cutting action by sharpening the grinding wheel with the help of diamond tool. Sharpening is done by breaking the abrasive so that new sharp cutting edge will expose. Main objective is dislodging the wheel, clean the wheel, break down the grains. These are the things, main objective in dressing. The next thing you have to know is truing. Truing is process of aligning the periphery of the grinding wheel so that it runs concentric about its axis of the rotation. This is done by the diamond tool. Process of aligning the periphery of the grinding wheel so that it runs concentric about its axis of rotation. So with the help of this, we are restoring the cutting action. By making this process, we are restoring the cutting actions. So that is called as truing. We are going to know about the grinding wheel nomenclature. When you purchase some grinding wheel, you have to specify with some letter, that is 5-letter code. First alphabet, number, alphabet, number, alphabet. So alphabet, number, alphabet, number, alphabet. When it is 6-letter code means maybe at the end of the thing manufacturer code will be given. When it is 7 means front and at the end the manufacturer code will be given. Here 5-letter is given. We have to remember attack gate to have a seat in bark. Attack gate to have a seat in a bark. So attack means A for abrasive type, gate G for grain or grid size, to have oddness or grade, a seat S for structure in bark bond type. So here A is given 45 A45 K8V, A45 K8V. This is the thing we have to ask in the when you purchase some manufacturers. So you have to tell like this, A45 K8V. The first letter represents the abrasive type. So it may be natural abrasive or artificial abrasive. The first one is solid stone or solid quartz. Example, silicon carbide, its trade name is carborundum. One company is available in Tiruvallur, carborundum company, used with non-ferrous component. The second one is emery. Emery is a mixture of alumina and iron oxide. It is aluminum oxide prepared by ore bauxite. It is white crystalline form. Trade name alundum. That trade name silicon carbide, carborundum. This is alundum. Next is corundum. Corundum is aluminum oxide plus iron. The example is cubic boron nitride. Cubic crystal structure is obtained, very hard but less than diamond. It is next to the diamond. Cubic boron nitride is whose hardness is next to the diamond. Next, diamond. Here in diamond, it is a natural abrasive. It is equivalent to that of cubic boron nitride and diamond are known as a super abrasive. When cubic boron nitride and diamond join together artificially, it is termed as super abrasive. Its hardness is, diamond is harder than CBN, CBN is harder than silicon carbide, silicon carbide is harder than Al2O3, Al2O3 harder than quartz. And the next thing is garnet. So here we are having two category: natural abrasive solid stone, solid quartz; artificial abrasive silicon carbide; natural abrasive emery, and artificial abrasive aluminum oxide; and natural abrasive corundum, artificial abrasive cubic boron nitride, natural abrasive diamond, artificial abrasive super abrasive, which is a mixture of cubic boron nitride and diamond, and we are comparing the hardness. The abrasive nomenclature can be represented by 5-letter code: alphabet, number, alphabet, number, alphabet. The first thing represent the abrasive type. So most usually abrasive are aluminum oxide and silicon carbide. Aluminum oxide can be useful for high tensile strength materials such as carbon steel, alloy steel, ardent steel, tool steel, high speed steel, tough iron, tough bronze, steel billets, ceramics, tungsten carbide. Less hard, this is less hard and more shock resistant than silicon carbide. And in silicon carbide, it is used for low tensile material, cast iron, brass, aluminum, bronze, and ceramics. The second letter is grain size. Grain size will be in number. If it is 8 to 24, it is coarser grain; 30 to 60, medium grain; 8 to 180, finer grain; 220 to 600, very fine grain. So the coarser grain suitable for ductile material and rough surface finish and soft material. It produces a fast MRR. And the fine grain is useful for smooth surface finish, suitable for hard and brittle material. The third letter is alphabet. It represents the hardness or grade. Grade represents the strength of the bond. A to H means it is soft grade. Soft grade is suitable for harder material. That means abrasive grain easily lodged. The abrasive grain can easily lodge in this case. I to P is the medium grade. QT is at the harder grade. Harder grade is suitable for softer material where the abrasive grain holds securely. So this is preferable for harder grade, preferable for softer material. And structure, dense structure means 0 to 7. It is suitable for hard and brittle finishing cut. Open structure 8 to 16 number means soft, ductile and or tough material. So this is the structure. Structure 8 means it is a open structure. So in this way we can find out what type of abrasive, what is the grain size, whether it is coarse, medium or fine, and what is the it is harder wheel or softer wheel, and the structure, open structure or dense structure. The last letter in the grinding wheel nomenclature represents the bond. The bond may be vitrified bond, silicate bond, resinite bond or synthetic bond, rubber bond, shellac bond, metal bond. Vitrified bond is the most commonly used bond. It can be represented by the letter V, and silicate bond by letter S, and resinite bond it is B because of bakelite, rubber bond R, shellac bond E, and metal bond M. This vitrified bond is the mixture of abrasive grain plus clay and water, also known as ceramic bond, not affected by acid or alkaline solution. So because it is commonly used because of this reason. Silicate bond is abrasive grain plus silicate soda. It is useful in low heat generation and it is a waterproof bond. And resinite bond or bakelite bond or synthetic bond is the abrasive grain plus synthetic resin. It is good for high speed grinding and used for rough grinding. The next one is rubber bond. Rubber bond is abrasive grain plus rubber plus sulfur. Here sulfur is added. It is also called elastic bond. It is useful for high speed operation. Regulating wheel centralized grinding is made up of rubber bond and more elastic, so soft on workpiece surface. Shellac bond, it is useful for good surface finish where abrasive grain is mixed with shellac, suitable for heavy duty operation. Shellac bond, it is useful for good surface finish. S letter represents good surface finish, H represents heavy duty bond, E is the symbol notation. So, She, you can remember the code word. Metal bond, abrasive grain plus metal used in the manufacture of diamond and CBN. In grinding wheel, speed is limited by bond, rigidity and grinding operation. When speed increases at constant feed rate, what happens? The chip size get reduced. High speed, it will cause crack developed due to the generation of heat perpendicular to the direction of the grinding marks. So, during the high speed, what happens? Crack will be developed due to the generation of heat perpendicular to the direction of the grinding marks. The grinding wheel should balance frequently. Why? Because of the random wear. The hardness of the grinding wheel can be, it is a resistance exerted by the bond against the grinding stress. How will you define the hardness? In grinding wheel, the resistance exerted by the bond against the grinding stress. This hardness can be represented by the alphabet. Hardness can be represented by the letter alphabet. So, large depth of cut will cause the increased wheel wear. Large work diameter also cause the increased wheel wear and decrease the heat produced. Large wheel speed, it will reduce the wheel wear. These are some of the points regarding the wear and the speed and balancing.